Greetings to all. Today in this video we will learn a new concept of atomic structure, that is Bohr's model of an atom. Next model after the Rutherford's was given by the scientist named as Bohr's. Therefore that model is known as the Bohr's model of an atom. What are the main points of the Bohr's model of an atom? After the failure of the Rutherford model, another structure or another model was proposed by the Bohr's. We know that the failure of the Rutherford model was the stability of the atom. So the first point of the Bohr's model about the stability of the atom. How does it explain the stability? For the stability, according to Bohr's model, electrons don't lose or gains energy by itself while they are revolving in the particular shell. Whenever electrons are revolving in different shells, they don't lose or gain energy, and their energy is fixed in its orbit. Therefore, these orbits are known as the stationary orbit, and these electrons are also known as the stationary because their energy is constant in this orbit. So the first point that was given by the Bohr's is electrons don't lose or gain energy while revolving in the particular shell. In a fixed shell or unfixed orbit. Next point, there are different shells are present around the nucleus. There are number of the shells which are present around the nucleus, and these shells are represented as K shell, L shell, M shell, N shell, and so on. Let us consider that this is K, then L, M, N, and so on. Also, these are represented as first shell, second shell, third shell, and fourth shell, and so on. Next point is when we supply the required amount of energy to the electron, then electron will jump into higher orbits or into excited state or into the orbits which is having higher energy. That higher energy states are known as the excited state for the electrons, and we can easily calculate that energy by the formula delta E is equal to E2 minus E1, where delta E is the difference between the energy of the two shells, E2 is the energy of the higher state, and E1 is the energy of its ground state. Similarly, when this electron loses the energy, then this electron comes into the orbit which is having the lesser energy. We can easily calculate the energy of the electron present in different shell by putting the formula En, where En is the energy of the nth shell, and the value of N is 1, 2, 3, 4 and so on. If electron is present in one shell or the first shell, the value of n is 1. If electron is in second shell, then the value of n is 2. We can easily calculate the value of the energy present in different shells, that is RH into 1 by n square, where RH is the Rydberg constant and its value is 2.18 into 10 raised to power minus 18 joule, and n is the number of the shell. For first shell, the value of n is 1. For second shell, the value of n is 2. Similarly, for third shell and fourth shell, its value is 3, 4 and so on. Next point, we can arrange, or Bohr's arrange the different shells in increasing order of energy. Means K shell has the minimum energy, L shell has greater energy or higher energy than K shell. Similarly, M and N both have higher energy than L and K. These different shells are arranged according to increasing order of energy. The shell which is having the lesser energy is filled first, and the shell which is having the higher energy is filled at the last. These are arranged according to increasing order of energy. The last point of the Bohr's model is all the orbits around the nucleus are not permitted or not possible. Only those orbits around the nucleus are possible which are having angular momentum integral multiple of the h by 2 pi. Only those orbits are permitted around the nucleus which are having angular momentum the integral multiple of h by 2 pi. And how do we calculate the integral multiple? How do we calculate the angular momentum for the electron? For the angular momentum, the formula is mvr, where m is the velocity of the electron, m is the mass of the electron, v is the velocity, and r is its perpendicular distance, and it should be integral multiple of h by 2 pi. So I write here n, where n is any integer. Its value is either 1, 2, 3, 4 and so on. Here m is the mass of the electron, v is the velocity of the electron, and r is the perpendicular distance from the nucleus. Here h is the Planck's constant, as it is constant, so its value is also constant, that is 6.63 into 10 raised to power minus 34 joule second. Pi is also constant, its value is either 22 by 7 or 3.14, and n is any integer. Only those orbits are permitted which are having an angular momentum integral multiple of the h by 2 pi. These all are the main points of the Bohr's model of an atom. This is all about the Bohr's model. In next lecture, we will read about the success of the Bohr's model or applications of the Bohr's model of an atom. I hope this concept is clear to all of you.